Ecosystem. Abiotic components and biotic components, the non-living physical and chemical elements in an ecosystem that support life, like solar radiation, prime energy input, climatic factors, temperature, wind and moisture, inorganic substances like nitrogen, minerals, soils, etc. These comes under the abiotic components, whereas in the biotic components, the living organisms that interact within the ecological network's structure produces autotrophic plants covering converting solar energy, consumers heterotrophic animals feeding on biomass, decomposes organisms recycling critical nutrients. Ecological principles, thermodynamics, energy enters as light, leaves as heat. Ecosystem obeys the law of energy conservation and continuous entropy increases. Biogeochemical cycles, critical elements like carbon, nitrogen, phosphorus, hydrogen oxide circulate continuously through pathways between biological organisms and physical environments. Interdependence, no organism exists in isolation. Biological communities adapt continuously through complex trophic foods, webs, and feedback loops. Ecosystem services and design, provisioning supply of water, timber, and building raw materials, carbon storage, local climate control, food mitigation, nutrient cycling, soil formation, habitat protection, recreational space, aesthetic values, and mental well being. Climate and energy. In terms of climatic responsive design, we have micro and macro climates. Modern structures must adapt to the local wind, humidity, and solar paths rather than relying solely on the mechanical HVAC systems, heat ventilation, and air conditioning systems. Passive orientation, optimize the solar angle exposure, building envelope, high thermal insulation performance, natural buffers, landscaping to divert or block wind. Microclimatic parameters, natural determinants. Local parameters influenced heavily by geography and organic surface layers, topography, elevation and slope angle aspects, vegetation, solar canopy shading and evapotranspiration, water bodies, diurnal land breeze and humidity buffers. In terms of urban interventions, artificial changes modifying local thermal balance in built up districts, surface albedo, high absorption rates of dark roofs, wind tunneling, canyon effect between high rises, waste heat, mechanical exhaust creating heat islands. Energy efficient design, minimizing the surface area to volume ratio reduces heat gains in summer and losses in cold periods. Using materials like concrete, stone, or brick to absorb heat during the day and release it slowly at night. Utilizing double or triple glazed windows with low emissivity coatings to limit conductive heat transfer. Thermal comfort parameters, air temperature, environmental, wall insulation, shading facets, thermal mass depth, mean radiant temp, double glazing installations, low emittivity surfaces, air velocity, window placement, courtyard stack effect, cross ventilation, relative humidity, natural cooling ponds, breathable hygroscopic plaster, clothing and metabolism, thermostat offset options, zone occupancy controls. So ASH or AE standard 55, that is the comfortable PMV range zero point 0.5 plus or minus, predictive mean vote, an index that predicts the mean value of thermal sensation votes of large group of people from scale -3 cold to +3 hot, maintaining an indoor PMV between minus zero point 0.5 to plus zero point 0.5 ensures that the predicted percentage of dissatisfied occupants remains under 10 percentage. Solar architecture, key structural concepts, exploiting the sun's seasonal paths directly through smart physical elements without active pumps or solar panels, direct gain,